Okay, so continue with pulley. So pulley is a device that can change direction of force. So from here we can see that this 10 Newton is a weight downwards. So in order to stop this 10 Newton from moving downward with acceleration, you need to produce a tension of 10 Newton upwards. So this 10 Newton upwards, okay, can be converted into 10 Newton downwards. That means if you pull, okay, if you pull downwards 10 Newton, so this 10 Newton tension straight along this rope over here, and the pulley changes the direction of the tension. Okay, the pulley change the direction of the tension from downward become upward. So that means we get a upward force even though we pull downward. So the pulley can change direction of force. Okay, look at the example. A boy is pulling a bucket filled with sand. The mass of the bucket with the sand is 3 kg. Find the tension in the rope if the bucket is stationary or moving up with a constant velocity of 2 meters per second. Okay, so you look at here. Okay, you look at here. So this bucket is 3 kg. So from here it gives that the weight is 30 Newton, but this is wrong, okay? This is wrong because this is because they base the G on 10 meter per second. Actually, G should be 9.81 okay, should be 9.81. So we don't want to use this as 30 Newton, Okay, we don't want to use this as 30 Newton. Alright, so we want to find out this tension is how much. So first, we need to find what is the acceleration. You see, it says that when the bucket is stationary. So when it is stationary, that means the acceleration is 0. Right now, acceleration is 0 meter per second. So if the acceleration is 0, that means this tension must be equal to the weight. Okay, tension must be equal to the weight. So you can straight away calculate the weight and the tension will be equal to the weight. Or you can do like in the lift. Okay, you can do like in the lift. So that means like this. F equals to ma. So this force give this mass this acceleration. Okay, so this force is the resultant force. So the resultant force will be tension plus the weight. Okay, equals to mass times acceleration. So tension is the one that we are looking for. The weight is mg. Mass is 3 kg. G is 9.81. Okay, mass is the mass of the bucket is 3 kg. And what is the acceleration? The acceleration is 0 because it is stationary. So tension will be equal to, see, this is I made a mistake here. I should put this as negative, okay, because gravitational acceleration is downwards. Gravitational acceleration is downwards, so I should put negative, negative 9.81. So what is it that I get is 29.43 Newton. Okay, 29.43 Newton. So this is the tension. So this tension is equal to the weight. Okay, if you take the mass times 9.81, so you will get 29.43. So the tension is equal to the weight. Okay, tension equal to the weight, then the resultant force is 0. Then the bucket is stationary. Okay, acceleration 0. Okay, now B, moving up with constant velocity of 2 meters per second. So you see, it says that moving up with constant velocity. So that means the acceleration is still 0 meter per second per second. So that means the tension, same thing, F equal to ma, tension plus weight equals to the mass times acceleration. But just now we already do one time this row, so we don't have to do one more time. So tension plus the weight is 3 times negative 9.81. Mass is 3, acceleration is 0. So the tension will be same to 9.43 Newton. So that means don't care whether it's stationary or it's moving up with constant velocity, both also acceleration is 0. Acceleration 0, that means the resultant force is 0. Resultant force 0, that means the tension must be equal to the weight. Okay, the force is balanced. Okay, the force is balanced. Okay, one more time, one more time. So if don't care whether stationary or constant velocity. Okay, velocity, the acceleration is 0. Acceleration is 0 means the resultant force is 0. 0 Newton. Resultant force 0 Newton means the weight equal to the tension. Okay, both sides same. Then only we can get resultant force is 0. Okay, get the idea. Or we can also show that the weight equal to the tension when the resultant force equals to 0. So for example, just now F equals to ma. Force is the tension plus the weight. Alright, ma. So the weight is downward, so it's negative. Okay, now if resultant force 0, so that means resultant force is 0. So that means this mass times acceleration is 0. Okay, so tension equals to weight. Because this is negative W, move over to the right, become plus W. So tension equals to weight. Alright. Okay, it says that the boy increases his force to move the bucket upward with an acceleration of 2 meters per second. Find the applied force. Okay, so how much is this force? Then this bucket can go up 2 meters per second acceleration. Okay, so again, this one it's not 30 but since just now at the top we already find the weight already, so we put as okay, the weight is is 29.43 Newton. Okay, 29.43 Newton Okay, we already found. Okay, so no need to find one more time Alright, so find the applied force. So same concept. You don't have to worry about. Okay, you don't have to worry about the boy part. Okay, you don't have to worry about the boy part. Okay, you just concentrate on the part with the bucket. Okay, you just concentrate on the part with the bucket. That means like this. Okay, just concentrate on the part with the bucket. So if you just look at this part, the bucket, okay, so you see here there are two forces. Okay, got two forces, the tension upward and the weight downward. So the resultant force, the combined force, give this 3 kilogram acceleration upward. Okay, so F equal ma, So this is the resultant force of these two. So tension plus the weight equals to mass times acceleration. So tension plus weight is downward, so negative 29.43. Mass is 3 kilogram. Okay, the acceleration is 2. Okay, so this, you see, this whole thing, this is the resultant force that give the mass 3 kilogram. Okay, when this force act on this mass have this acceleration. Okay, so this force act on this mass have this acceleration. Okay, see that. Okay, so let's solve lah. Okay, tension equal to, okay, we get 35.43 Newton. Okay, 35.43 Newton. Okay, so you see this is the tension is larger than the weight. This is very logical, right? Okay, because the bucket is accelerating upward, so that means the force upward must be larger than the force downward. Then only it can accelerate up, right or not? Okay. All right. Number 1 exercise. Okay, so two mass of 5 kilogram and 3 kilogram are connected to a rope which passes over a frictionless pulley. Find the tension in the rope and the acceleration of the 3 kilogram mass when the 5 kilogram mass is released. Okay, find the tension in the rope. Find the tension in the rope and the acceleration of the 3 kilogram mass. That means this 3 kilogram mass, how much is the acceleration? When the 5 kilogram mass is released. Okay, so you see you look at the story, it says that what is the acceleration of the 3 kilogram mass when the 5 kilogram is released? Why is it that when 5 kilogram released, the mass, this 3 kilogram will accelerate up? Because this 5 kilogram is heavier than the 3 kilogram, right or not? So that means the weight of the 5 kilogram must be larger than the weight of 3 kilogram. So for example, here it gives 50 Newton and 30 Newton, but again, this is incorrect because this 50 and 30 is based on old syllabus. Based on old syllabus. Okay. So in new syllabus, we calculate the weight using G equal to 9.81, not G equal to 10. Okay, so this 5 kilogram have larger weight than 3 kilogram. So that means the force that pull downward over here is larger than the force that pull downward on the 3 kilogram. So that means this 5 kilogram weight will be able to pull the weight of the 3, will be able to overcome the weight of the 3 kilogram and make the 3 kilogram accelerate up. Okay, get the idea. So how to find the tension? Okay, how to find the tension? Alright, so the simplest way is you make it look, you change this situation into something that is not complicated. You change this into something that you always see. That means like this. You take that. This is 5 kilogram. And then connected here. 3 kilogram. And this 5 kilogram, there's a force here. This force is the weight of the 5 kilogram. We put it over to the left side. And then this 3 kilogram also got force pull. This direction. This is the weight of the 3 kilogram. Okay, like this. So, because this weight of the 5 kilogram is higher than the weight of the 3 kilogram, so that means everything will accelerate in this direction. Okay, you see or not? So you see, when you draw, when you make it into this kind of situation, actually this is the same as this one, right? These two is actually the same. Okay, these two is actually the same. So when you put it this way, then it becomes something that you are familiar with, something that you do before. Okay, something that you have experience with. So it makes the situation more simple. If like this, you feel very confusing. Got accelerate down, got accelerate up, tension both sides, and so on. But okay, please keep in mind, make sure that, okay, you must remember that this tension is equal. This tension is the same. Tension in the rope is all the same. Okay, tension along a rope is all the same. Okay, so if we look from the 5 kilogram perspective, this is the weight, which is the gravity pull on the 5 kilogram, and there is a tension in the opposite direction because these 3 kilogram also have weight. So the weight of the 3 kilogram pull and produce a tension here that work against the 5 kilogram. If you okay, so that is the from the perspective of 5 kilogram. If you look from the perspective of 3 kilogram, this weight pull to the right, but there is another, this one, this weight, this force pull to the left. So this force that pull to the left will produce a tension that act on the 3 kilogram and give this 3 kilogram this acceleration. Okay, now, so okay, have to use simultaneous equation. Okay, have to use simultaneous. No need simultaneous equation at all. Okay, no need simultaneous equation at all. Okay, so you see, so we take that this whole thing is together. Okay, we take this whole thing as together. So again, F equal to ma. This force, weight. This is the two force that act on this whole thing. Okay, this weight and this weight act on the 5 kilogram and 3 kilogram and give this 5 kilogram and 3 kilogram this acceleration. So that means this is the weight of the 5 kilogram. I put W1. This is weight of the 3 kilogram. I put W2 lah. Okay, so W1 plus W2 equals to mass times acceleration. Okay, W1 plus W2, you get the resultant force that act on the 5 kilogram and 3 kilogram. Okay, so W1 is mass times gravitational acceleration. So 5 times, okay, so because this is going to the left, so we take it as negative lah. Okay, negative 9.81. Okay, this W2 is to the right. So I put 3 times negative, positive 9.81. Okay, so the mass is 5 kilogram plus 3 kilogram. Acceleration is the one that we are looking for. Okay, so with this we can find the acceleration. Okay, we will be able to get negative 2.4525 meter per second. Okay, so this is the acceleration that you get. Negative 2.4525 meter per second. Okay, so so they want us to find the acceleration of the 3 kilogram mass, and so because acceleration is upwards in the real situation, in the actual situation the acceleration is going upwards, so it is positive lah. So that means we cannot put, we cannot just leave it like this, negative 2.4525. so we have to answer the question lah. Okay, so we have to say acceleration of 3 kilogram mass equal 2.4525 meter per second. Okay? We have to answer the question based on the actual situation. This one we put it like this is so that we can make the problem more simple. Make the problem more simple to solve. Okay, now next. We want to find, we already found the acceleration. We want to find the tension. We want to find the tension. So in order to find the tension, we only need to look at from one perspective. That means from the perspective of the 5 kilogram or the perspective of the 3 kilogram. Don't care from which side, you can also get the tension. So let's say that we look from the perspective of the 5 kilogram. From the perspective of 5 kilogram. 5 kilogram. So we have the weight to the left and the tension to the right. And this 5 kilogram have acceleration of 2.4525 meter per second. So F equals to MA. This force is the weight and the tension, these two. So W plus T equals to MA. Alright, so this weight is 5 times, because to the left, so negative 9.81, plus the tension. Tension is what we are looking for. So the mass is 5 kilogram and the acceleration is, because accelerate to the left, so left is negative, because here left, negative. So we put negative 2.4525. So the tension is, we get 36.7875 Newton. Now, so this tension is in positive this tension is in positive. So because this tension from the perspective of the 3 kilogram is going upward. It's going upward. Tension in the rope. So the tension in the rope is actually, when we calculate tension, at the end we have to put the tension as positive. We have to put the tension as positive in the final answer. In the final answer of tension, we need to put the tension as positive. Why is it positive? Because the tension act in both directions. You see or not? The tension act to the left, act to the right. At the same time. Act to the left on one object and on another object act to the right. So kind of like tension can be in any direction. So we don't differentiate positive or negative. So we just at final answer only. At final answer we put the tension as positive.